Assalamu alaikum wa rahmatullahi wa barakatuhu. I am Sir Rifat Ali, once again in front of you. As we have discussed last time, proportionality, and a reference I have given you, New Syllabus Mathematics Book 2, Chapter number 1. Okay, we have completed its first two topics. We have defined what is proportionality and direct proportionality. Its first type, direct proportionality, and we have discussed their presentation, mathematical presentation and graphical presentation. We have discussed about it, and also I have solved two questions with different nature, one related to relation or equation connecting x and y, and one without connecting x and y but direct answer. Okay, now today I'm going to explain inverse proportionality in the same way and same sequence we have done last time for direct proportionality. Okay, now we always consider two physical quantities at a time whenever we discuss a relation, that is known as proportionality. So for inverse proportionality, the definition would be like this: on increasing the other one will decrease with the same rate. On increasing one physical quantity, the other one will decrease with the same rate. As one is increasing, other one will decreasing but with the same rate. And on decreasing one physical quantity, the other quantity will increase with the same rate. So the two quantities are in opposite direction. So rather than saying on decreasing one, other one will increase with the same rate, uh, we write down the same rate and vice versa, meaning to say same process in opposite direction. Okay, this is the definition of inverse proportionality. And in comparison, if you have done direct proportionality, you can easily remember this one in comparison of this one. So over here in direct proportionality, on increasing one, other one will increase with the same rate. So on increasing one, other one will decrease with the same rate. This is inverse proportionality, also known as indirect proportionality. Okay, what is the mathematical representation? Just for solving question. Mathematical presentation. Okay, now what is the mathematical presentation? If we consider two quantities x and y, one depend on other, then y is proportional, y is inversely proportional to x. So in mathematical language, y is inversely proportional to x. One is we place the quantity in denominator in case of inverse proportionality. In case of direct proportionality, we place the quantity in numerator. Place the quantity in numerator. But listen, the sign of proportionality remains same. So y inversely proportional to x, and do not say y inversely proportional to what upon x, right? So y inversely proportional to x, in case of inverse proportional relation, the value must be placed in denominator. We place the value in denominator. So y inversely proportional to x, and the next step, we remove this sign of proportionality by placing x. So k time 1 upon x, y is equal to k time 1 upon x. So this is the relation. After putting the value of k, we can find out an equation connecting x and y. If these two have inverse proportionality, these two have inverse proportionality. So it means y inversely proportional to x, or y is equal to k times 1 upon x, and we know this x is in denominator. When shifted over here, it must be multiplied. If it is multiplied, so one can say xy is equal to k. What does it mean? In case of inverse proportionality, we always have a common product. We have a common product. Okay, now over here, in case of direct proportionality, we have a common ratio and we perform cross multiplication. And I have told you, in case of inverse proportionality, we will perform straight multiplication. Okay, when we solve the question, I will show you. But right now, y inversely proportional to x, y is equal to k time 1 upon x, or xy is equal to k. Xy is equal to k. This is a relation between two physical quantities that are inversely proportional to one another. Okay. Now, what is the graphical presentation? This is the mathematical presentation, and we must utilize this formula in case of solution, right? So we will use this formula when we solve the question. Okay, now the heading, next heading is graphical presentation. Okay, this is graphical presentation. Graphical presentation. Okay, in case of direct proportionality, we have a straight line generating from origin. A straight line generating from origin. This is the graphical presentation of direct proportionality. But right now, I'm going to write graphical presentation of inverse proportionality. Okay, now listen. Always have a parabolic curve. We always have a parabolic curve. A parabolic curve is obtained when there is a relation between two quantities which are inversely proportional to each other. So, a parabolic curve is obtained when there is an inverse proportionality. A parabolic curve is obtained when two quantities are connected through inverse proportionality. Okay, okay, sketch the graph for inverse proportionality. Listen, draw two axes, x and y, and a parabolic curve. We can draw like this. This is parabolic curve. So what it show? What does it show? Now listen, if I consider over here This is x1, this is y1. On increasing the value of x, there is a decrease in the value of y. This is y2, this one x2. Further increase the value of x, there is a decrease in the value of y. So if we decrease the value of y, x increases. If we increase the value of y, x decreases. So one of them is decreases on increasing the other one. This is inverse proportionality, and this is the graph. This is the sketch of a relation when two quantities are interconnected through inverse proportionality. We always draw the same graph. Okay, now I'm going to solve some question related to inverse proportionality. Okay, now the question is question number 1. If y is inversely proportional to x, if y is inversely proportional to x, if y is inversely proportional to x and y equal to 4 when x equal to 3 and y equal to 4 when x equal to 3. Okay, now this is the question. If y is inversely proportional to x, now there is a relation between y and x. These two are connected by inverse proportionality, and y depend on x, and y equal to 4 when x equal to 3. One set of information given just to find out constant of proportionality. Okay, now first part, this is the first part. Express y in term of x. Express y in term of x. Okay, express y in term of x. So listen, according to the given statement, the mathematical formation would be like this: y inversely proportional to x, y inversely proportional to x, like this. In case of inversely proportional, we always place the value in denominator. So y inversely proportional to x, right? Okay, now it means y is equal to k times 1 upon x. Okay, put the value whatever given, a complete set you are given. Y equal to 4, x equal to 3. So y equal to 4 and x equal to 3. This 3 is divided over here. When comes on the other hand, it would be multiplied. Now 3 for the 12. So the value of k is 12. Now put this value over here. Y is equal to k is 12. So 12 ones are 12 upon x. Now this is an equation connecting x and y. This is the relation between x and y, or express y in term of x. So y equal to 12 upon x. This is the first part, and we have made a relation between x and y. Now if we are given some points on x-axis, we are able to find out relative point on y-axis. We are given a point on y-axis, we are able to find out related point along x-axis. Okay, now what is the second part? After it, the second part is find the value of y when x equal to 6. Find the value of y when x equal to 6. Okay, now listen. This is the second part. Find the value of y when x is equal to 12. Okay, when x equal to 6. when x equal to 6. Okay, now listen. The value of x we are given, and we have to find out the value of y, and we have a relation, we have a formula. Just put the value over here, this is input, and we can open an output. So we can find out y by putting the value over here. So y is equal to 12 upon x. 12 divided by x, what is the value of x? 6. So by dividing these two numbers, y is equal to 2. So the relative value of y is 2 when x equal to 6. Okay, now the third part. Draw graph of y against x. Okay, draw the graph of y. Draw the graph of y against x. Draw the graph of y against x. Okay. Okay, now listen. What would be the answer? Just draw two axes. This is x, this is y, and do not try to take accurate value. Just draw this type of curve like this. Okay, now listen, we are given two set of information. One is given over here, one we have solved to make it complete. So x6 y2. Okay, x6 y2, let's suppose 1 2 3 4 5 6. So this is 6. Then what is the value over here? When x equal to 6, y equal to 2. Okay, this is 2. Okay, now when x equal to 3, 1 2 3, what is the value? When x equal to 3, what is the value of y? It must be greater than 2. Yeah, of course, y equal to 4. So just listen. If we decrease the value of x, the y increase. This is inverse proportionality. And we have the same graph always. If I place a value of 1 over here, the y will increase. Let's suppose if I place a value of 1 over here, right? If you place a value of 1 over here, then 12 divided by 1 will give you 12. So if we place, if we decrease further the value of x, the y will increase. Okay, now this is the third part. This is a complete question. In step number 1, we find out a relation between x and y. Second part, we follow the formula, whatever we obtain by the process. Okay, now the third part, draw the graph of y against x. Now the same shape as I've told you. Whatever we have done in the theory, we have the same shape, and it must follow the graph. Okay, now the second question, in which we will be able to find out the direct value, right? So we will not format a relation, but we are able to find out the direct value. How? Now let's see. Question number 2. If z is inversely proportional to w plus 3, if z is inversely proportional to w plus 3, inversely proportional to w plus 3, and z equal to 4 when w equal to 3, and z equal to 4 when w is equal to 3. Okay, now the same information we are given. Yes, one complete set we are given, and a relation is defined in the question. What is the relation over here? Inversely proportional. Okay, and w equal to 3. Find the value of z when w equal to 9. Find the value of Z when W is equal to 9. This is the complete question. Okay, there is no question, no requirement for a relation or an equation connecting Z and W, right? Just Z is inversely proportional to W plus 3. So it means we have to write what? According to the question, Z inversely proportional. Inversely meaning to say we have to place the second physical quantity in denominator, right? Remember this point. We should place second physical quantity in denominator. If the words are used, Z is inversely proportional to W plus 3, we must write down like this. We must write down like this. Okay, now listen. In this process, we have a common product. So in the formula, we must place the second quantity in denominator. But when we substitute the value W plus 3, we will write in numerator and will multiply straight multiplication. We use straight multiplication. If I write over here 1 upon something, then I can take cross multiplication. Okay, the same sign is over here. Okay, now listen what we are given. Z is 4 and W plus 3. When W equal to 3, put the value 3 over here. 3 plus 3, 6. We have to place the value of W equal to 3 in W plus 3. As there is no relation between Z and W, there is a relation between Z and W plus 3. So when W equal to 3, put the value over here. 3 plus 3, 6. So you must write down 6 over here. You must write down 6 over here. Do not write down in denominator. Do not write down 3 over here. The relation in between Z and W plus 3. So if you are given the value W equal to 3, first place it over here and then calculate 3 plus 3, 6 and write down over here directly. Okay, now find the value of Z. Find the value of Z. Write down Z over here. When W equal to 9. So we should not write over here 9. We never write 9 over here. So W equal to 9. First place it over here or over here. 9 plus 3 is 12. So we will write down over here 12. Right? We do not write over here 9. We write over here 12 as the relation in between Z and W plus 3. So put the value of W equal to 9 over here and 9 plus 3, 12. Okay, now this is inversely proportional. In inversely proportional, there is a common product. So there is a common product, we will multiply in split. Right? We do not multiply as a cross multiplication. Straight multiplication. Okay, now 4 multiplied by 6. 4 multiplied by 6 is equal to Z multiplied by 12. Z multiplied by 12 and 4 6 are 24. This 12 multiplied over here, come over here in division, equal to Z. So 12 ones are 12, 3s are 24. So the value of Z equal to 2. Okay, I am repeating my words again. Listen, the relation in between Z and W plus 3. There is no relation between Z and W. No relation between Z and W. The relation in between Z and W plus 3. So always place the value of W first in W plus 3 and then keep it over here. Then write down over here after calculation what is the value of W plus 3. One physical quantity is Z, other physical quantity is W plus 3 and not W. Right? We consider W plus 3 as a whole. It is a one physical quantity. So don't make a mistake by writing the direct value of W. Write down the value of W, whatever there is a relation. Okay, so answer would be Z equal to 2. Right? This is the answer. Now listen, I have given you a theory and solved two questions for direct proportionality and two questions for inverse proportionality, right? I have taken x cube and x square y cube as well, just to clarify, okay, what should we do in this case or in that case, right? And I think if you read the theory again and again, if you concentrate over here, you will be able to solve all type of question. This is called one set of information. Sometime it is given in the boxes and we have to fill the remaining boxes. The same thing. But if we are going to find out 2 or 3 or 4 values, so do not try direct method. First find out a relation and again by putting the given value, find out the other value. This is the right way to solve. But if we are going to find out just one value, if there is a single part as like this, so I think if you first make a relation and then put the value, it takes more time, more space, right? So in such a question, make direct calculation like this, okay? If you like this video, please like it, right? Subscribe it, press the like button, press the bell icon, comment, share it to your friends so that we'll be able to see like other videos. Thank you. Allah Hafiz.